Welcome back to our special report of the tragedy of the Space Shuttle Columbia. We're going to be talking to Story Musgrave in just a moment. Before we do that, let's get an update on the latest facts as we know them from Anderson Cooper. Anderson?
Miles, thanks very much. We can report that human remains have been recovered from the debris field in Hemp Hill, Texas. Authorities are assuming they may be that of Columbia crew member. Shuttle debris is being found in yards, fields, and various other places throughout the state. People are being cautioned against touching whatever they might find because it might be toxic. In honor of the Columbia crew, President Bush today ordered flags on all federal buildings to be flown at half-staff until Wednesday. The governors of many states have done the same. We're now going to check in. Actually, we'll just go back to Miles O'Brien. Miles?
All right, Anderson, thank you very much. You know, one of the reasons we explore space is to push the boundaries of science. And for the Shuttle Columbia, the 16 days in space have been completely earmarked for scientific experiments. Not exaggeration to say that years and years of effort went into getting these scientific experiments together, and in this case, to fly on this particularly long science mission. The Columbia carried experiments on changes in the spread of flame in space. Flames do not burn like they do here in the world of gravity, an important thing to know when you have an ongoing International Space Station. Also, flowers that grow in space don't smell the same. Why? Well, we don't know. That was one of the experiments. The effects of weightlessness on rats and how that might relate to human beings who spend long-term stays in space. Measurements of atmospheric dust. This was the prime experiment for Ilan Ramon, the Israeli astronaut. He was looking at how dust might have something to do with global warming, particularly looking at dust storms in the Middle East. And B, and spider behavior and weightlessness was also looked at, all in the quest for learning more about the human body performs, and in some cases doesn't perform, in the absence of gravity. All that with an eye toward further exploration one day in space. Now, more than one former astronaut was probably reliving a mission or two before today's events went horribly wrong. With us is Story Musgrave, a veteran of 6 space flights, and Mae Jamison, the first African-American woman to fly in space, who flew one mission in 1992. I want to begin with you, Story. You had the opportunity on your last mission to make some observations about re-entry and the heat that is encountered when a shuttle re-enters the atmosphere. Tell us a little bit about what you saw and what impressed you about it.
Yes, Miles, I think heat rejection is a critical factor in what happened today. And to get a real feel for how much heat you need to reject, if you look at a launch, the external tank, how much fuel, the solids with how much fuel, all of that energy that goes into a launch has to come out on the heat of re-entry. And so if you look at burning up the amount of fuel that is carried, it has to come out in the heat of re-entry. On STS-80, my final flight in 1986, after an 18-day flight, I had no responsibility, no technical responsibility during the entry. So I had the opportunity to simply stand with all my gear on in the flight deck and look out the overhead window. So from your point of view, if you'll have the nose going that way, the tail toward you, and I am here looking out the overhead window, from Mach about 23 down to Mach 10, the amount of fire that you are engulfed in, you cannot believe that you are not evaporated in a flash. But what is amazing is you are absolutely enveloped in this flame, but the flame paints your shock waves. And so the flame is a medium, and you see the supersonic shock waves in there. You see this blue lightning coming off the nose that is energizing this whole pattern. Whenever a rocket jet, an attitude control jet goes off, the whole thing dissipates, and it comes back in a flash.
Wow.
And I did, standing up, I was able to hold a camcorder in the window and record that and show my fellow crew members with a little monitor. What was amazing is in the S-turns for navigation and to manage our energy, in those S-turns on one side of the tail I had a different auroral color, and on the other side I would have a different color.
That's fascinating.
And this was really amazing to me.
When you witnessed that, you had to be impressed with how much work these tiles have to do. These little tiles, little teeny pieces laid together like bricks, which are very fragile and yet really hold your lives in their hands, if you'll excuse that, giving it personification. But nevertheless, it's a fragile system and yet a hardy system, isn't it?
I would call it a fragile system. I'd call it a very critically vulnerable system in which everything has to come out perfectly. I look upon launch as a beautiful butterfly that's bolted on a bullet. But today, of course, the emphasis is on re-entry and how tens of thousands of tiles have got to do their thing.
Let's go to Mae Jamison. Mae, you flew in 1992, and did you have a similar experience on re-entry? Did you have this sense of being enveloped in tremendous heat?
Well, what Story described really talked about looking out the window. When you're actually seated, you don't have that sensation. Basically, what you're feeling is that all of a sudden you're getting weight again. You've been in space for a number of days. The members of the crew who are on the flight deck are watching the computers, watching what's going on to try to make sure that nothing is going awry. But you don't actually have that feeling because you're not seeing it, which is what's remarkable about what Story was able to observe.
It seems like a wild ride, Mae, is it?
Coming back in?
Yeah.
It doesn't, no, you're bleeding off a lot of energy, but what's going on inside of the shuttle, I didn't feel like it was a very wild ride. In fact, it was fairly tame from what you'd expect. But I think that the comment you made about the tiles is very true. The tiles do an incredible amount of work because they have to insulate the shuttle in a very small distance of space. And they've done that task many times.
Story, let's go back to what you were saying about it being a fragile system. That in a way, I think a lot of people would say, wait a minute, fragile, it's coming in at, beginning at Mach 25, slowing down to 0 ultimately at the runway, shedding off heat all the while, entering the atmosphere under tremendous stress. Surely it has to be a hardy system.
No, sir. I don't look upon it as a hardy system. The engineering has to be perfect, and the engineering has been perfect. It's a marvel that the system has been able to pull it off. I still call it a very, very fragile system. A tile is like this. A tile is about this thick, but it weighs nothing, and you can feel it even when it's almost white hot because it has no heat capacity. You can push your finger right into it. All of that has to work. You can have Mach erosion, in which you're supersonic. You can have Mach erosion. It can eat you into pieces. There's all kinds of very high-tech engineering involved.
I'm curious what you're...
Go ahead, Mae. Go ahead. Comment in the
Please
terms
do.
When you talk about fragile, I would think of many times when you talk about systems as fragile, if you talk about the human body as fragile, if you find if the right problem, the right accident comes along, then something that seems relatively minor can be catastrophic. But at the same time, the human body is remarkable. I think if you look at it in fragile in that sense, then you'll get a better feel for what Story is describing, that it has this tremendous precision engineering that has worked over and over again. But if you get to a point where you have the right accident, then something catastrophic can occur.
That's an interesting analogy. I hadn't heard it put that way, but that seems to make a lot of sense to me. Story Musgrave, we've been talking a lot about that piece of foam which fell off the shuttle on ascent not long after liftoff. Struck the left wing. NASA looked at it, didn't determine that there was anything really serious there, or that was the conclusion, at least at the time. Do you think that that is ultimately going to be a dead end, or is that something that ultimately will lead to some sort of conclusion as to what went wrong?
I am sorry, Miles. I just don't have the technical information. I just don't know what to say on that one.
All right. Well, we appreciate you being honest and candid and not getting into the realm of speculation. Mae Jamison, your thoughts. Do you feel fairly confident that NASA is going to, as Bill Reedy described it earlier, head of human spaceflight, said, we'll find it, we'll fix it, and we'll move on. Do you think that's going to happen?
I think that definitely an answer will be found, and I have a feeling it'll be found very quickly because remember the shuttle has an incredible amount of data and telemetry that's coming down constantly, and an answer will be found. we'll figure out how to fix some parts of it. You can't say that every phase of human spaceflight is always going to be survivable, nor can we make it survivable. But how we move on with the space program is really going to depend on the commitment of the American public and how we react to this.